and the invitation. I'm going to talk about a few things in the next slide. Basically, our proposal and what we're working on is to deliver the next clean energy, energy revolution by getting clean hydrogen directly from the rock. Today, I'm going to talk about three things. First, I want to recognize collaboration. And today is a big moment for us because we completed the concept study with Shiyoda right here of the world's first plant for processing natural hydrogen. So today is a big day because we have achieved as a society that important technical milestone. Till today, it didn't exist a concept plan on how are you going to take what comes out of the ground and process it and get it ready for sale. I think today is also a day that I want to kind of nurture collaboration in Japan and say I don't want to leave collaboration just today. I want collaboration to continue because I think it will benefit us all. Recently it was talked about the importance of collaborating with data and other things, so I'm going to talk a little bit about that because I don't have to talk today. And then I'm going to tell you a little bit about Geokiln, our company. Myself, I'm a believer that you are as strong as your weakest link. So therefore, during my career, I have tried to stay broad and cover the entire value chain. So I'm a specialist in technology, but also in development and operations. Mostly of that experience coming from my days in Shell. And you can tell by my education that I cover both the technical side, the business side, and the environmental that is so important. So in terms of nurturing collaboration, I came here in Japan not only to complete the concept study and determine the next steps. We will continue. We now have to move into basic engineering of the plan for our first commercial project, and we plan to do that in the next couple of quarters. But I think other elements of collaboration that we think it's important and I wanted to share with you is, for example, understanding geologic potential, right? Because that's where it all starts. And a couple examples there you can see from the Bureau of Economic Geology from the University of Texas. They published a more detailed map of where location prospectivity for stimulated hydrogen could be. And on the other example, I have the government of Oman, who generously sponsored the Oman drilling project that created great characterization, and all that data is fully available. I think for us to progress in Japan, we need to find a way to create these ecosystems of information so companies and the government can work together in determining the areas. Another area where I think it's important to work is working with the communities. We may find the locations being in places of sensitive locations for cultural heritage reasons, natural habitats, etc. But I think I can tell you the industry has effective ways of dealing with that, and I think the LNG Canada project, which was a venture between Shell, Mitsubishi, and others, was very successful at that. And I can tell you the secret sauce is very simple, and it's shown by the pictures there. It's really understanding what the sensitivities are in nature, and then working directly with the community, drafting a plan together on how to move forward. But I think definitely looking into Japan, we want to do our developments, Geokiln, in a very respectful way and taking care of all those considerations. So we're really willing to sit down with the communities and other parties to develop our plans. So let me tell you a little bit about Geokiln now. Hydrogen demand is forecasted to be pretty high, but we really have a cost problem. Gray and green hydrogen it doesn't make the mark in terms of cost or being clean enough. Geokiln at $1.50 a kilogram by doing stimulation, it is the solution. So basically, we are bringing a cost solution to the problem. Now, our solution to the problem of cost is being done by existing thermal technology. We're not creating a new technology to do this. We're borrowing technology already doing in the oil and gas industry. In this particular case, what the picture shows with the red lines is electrical heater wells that are placed in the formation to take the rock to the temperature of serpentinization. And then the blue rod represents a production well which is open to production and will collect the gases as they get produced. To do this, again, we don't need any new type of hardware. We use off-the-shelf hardware. Of course, Geokiln is creating our own proprietary subsurface simulation and engineering, and we're protecting that vigorously through continuous patents. Part of our cost solution also have synergies with natural hydrogen. People that are looking for geologic hydrogen are our natural partners. And the way the partnership works is that as they looked and characterized the source rock in the left that is deep, that is reactive, we prepare our developments higher up in the earth where the temperature is not as hot, and we bring that temperature in order to do what Mother Nature is already doing, and doing it at a time scale, and a scale that is commercial. So again, we work with great synergies with producers of natural hydrogen. Now, our cost solution is massive and well located. I spent about 15 years of my experience working the unconventionals, and 10 of that is in the United States. And this map here is the version of the United States Geological Survey that is specific for thermal stimulation. And the thing I love about this map-to-map comparison is that it shows that the potential of this resource is the same in scale or even larger than oil, shale, and shale gas it is today. I like to stress the fact that shale oil and shale gas supplies 2/3 of the gas and oil needs of the United States today, 2/3. But we didn't know about it until 17 years ago. So people today that do not believe that we can do something onshore with a good natural resource at scale within a decade, they're wrong. The shale revolution has proven that it can be done, and the commitment of Geokiln is to drive that and be next. The geology is also not only a U.S. phenomenon. In Oman and the Emirates is being characterized, and also Saudi Arabia is doing its part on creating the resource. Our cost solution is not only massive in the U.S., but it's massive in other parts of the world. The way we validate our technology fit for the geology is pretty simple. We retrofit existing vertical wells with our heater, and we heat for a period of time and collect samples of gas. And if we like what we see, we just place another well beside it and heat for a longer period of time and look for about 0.1 to 0.3 tons per day to create the initial type. So our de-risking process can be done within 6 months, 8 months, and a year, depending on a few logistic items. So pretty simple, pretty cost effective. Our company Geokiln has many years of experience with people branching from different types of expertise, from our founder and CEO, Alexei, who's an expert on thermal heating. Lauren Ortiz, who's here with me, our Chief Commercial Officer, having done technology commercialization in shale in many different ways. Natalia Branch, our CFO, who has experience in very large capital projects in the Gulf of America. And Robert Dombrowski, who was also an engineer with me when we were doing thermal stimulation in Canada. And our latest addition, Katie O'Shea, with great experience from Exxon on the project engineering side, and also great experience on the marketing side. So we are a company with the expertise to cover, again, the entirety of the value chain. 2025 was a great year for us. We initiated our collaboration with Hytera. Bill Gates Breakthrough Energy Foundation gave us our pre-seed funding, and we started a collaboration with Toyota, which we are completing today, the first phase. We expect 2026 to be even a better year. So the black pinpoints in the map represent the places where we're screening our geology. So we're covering the world, and we want to add Japan pretty soon with direct studies. That is the reason we're here today. We want Japan to be there, and our objective is by 2028, take final investment decision on 4 locations so we can start production in 2030. Geokiln, I want you to think of us as a competitive hydrogen value chain builder. We don't stick with just technology, we don't just stick with the risking, we go end to end. We start obviously screening our partners' geologic potential. We look at that, we look at the solution fit of our technology, but then we apply the years of development experience that we have, project planning, process facility planning together with Shiyoda. And then after that, we go into the two elements that are also very important to preserve value, which is offtake agreements and significant supplier engagements and agreements, because also our suppliers are a very important part of the equation. So we are an end-to-end solution builder in the space of hydrogen. So our path to global hydrogen, before I give the floor to my colleague at Shiyoda, we're looking into developments that are about 180,000 tons per year, done by three trains of 60,000 per year. We're shooting for less than $1.50 per kilogram with no subsidies, low emissions, and global reach. And we're here to at Geokiln. Thank you.